Hello everybody, hope you're doing well and thanks for joining us for another video. Now, usually my videos either tackle people's misconceptions about the moon landings or they address flat earthers getting everything wrong about the shape of the earth. Well, today we're going to combine them and address a flat earther that's getting everything wrong about the moon. Because the other day I noticed a few posts on X from flat earther Trevor Long. Now, he posts a lot of flat earth material on there. But the other day I happened upon a few posts of his related to the moon and how he thinks the moon itself is fake. This one, which he shows a zoomed out view of the moon and then two zoomed in shots, and the post states, "A camera changes the bright moon manipulation of light style. These were taken one after another." Then this post with a photo of the moon showing earthshine and states, "The sensor never literally captured this shot. The camera superimposed it from deep fake lunar data. Even cameras lie to fake craters to get you to believe it's a rock that can be landed upon. You can't land on a lie." And these seem to be making the same basic claim, given that the post shows the moon when zoomed out appears as a bright circle in the sky, and then you zoom in and you can see the details of the craters, and he's stating that the camera's changing the brightness of the moon. It seems he's claiming that, same as the other post, the camera is artificially adding the detail of the moon into the image. Either that or he's referring to the shifting colour between the two zoomed in shots, that the moon is more yellow in one than the other. So let's address these, because obviously it's not that the cameras are artificially creating the moon in photos, it's simply common traits of how cameras work that any photographer will be happy to verify. So firstly, with regards to the shadows of the moon being AI generated by a camera, I think he overlooks that AI is a pretty new technology, and yet cameras have been around for far longer. Now, I will concede the idea of AI generating the moon isn't entirely untrue, in that phones often do such. Phones these days get marketed with insane zoom levels. For example, my OnePlus 13 is claimed to have a maximum 120 times zoom. The Nikon P1000 only has 125 times, despite it having a huge optical lens, whilst my phone has three small lenses which don't optically zoom. The 120 times is simply taking the 3 times optical lens and digitally cropping in. But cropping in is just throwing away most of the pixels of the sensor and only recording a few in the middle of the sensor, which then makes everything very grainy and low resolution. So phones these days will often use generative AI to try and fill in the blanks to artificially increase the resolution of a photo. For example, if I zoom in on a wall in the distance, the initial photo is very grainy, but then a few seconds later, the phone generates this much better looking version. Now, this is simply the phone using AI to try and work out what the image contains and then trying to render a better version of it. But it's clearly AI rather than the actual quality of the camera. It can handle a wall because those are easy to recognize. But if I do this with small text from across a room, it'll generate a far less grainy photo, but the text is illegible. So phones do use AI on highly zoomed in photos. And sure, higher end cameras now are beginning to utilize AI deep learning within the camera for the likes of autofocus. Some modern cameras now will use deep learning to try and predict where subjects will go in order to keep them in focus. They can lock onto a specific subject and recognize that subject to be able to follow where it's going, and if the subject gets obstructed behind another object, the camera can recognize this and not immediately start jumping around to lock onto something new. Many cameras have subject detection. Now, like my camera has eye tracking autofocus enabled, but I can set it to human, animal, or bird, and the camera will then follow that chosen subject's eye. But A, that's just AI, not generative AI, which is what would be changing the actual finished photo. And B, this again is new technology for cameras. Most new cameras these days are mirrorless. So when you look at the back screen or in the viewfinder, what you're seeing is an image from the camera sensor as the camera sensor is seeing it live. But only a few years ago, most cameras were DSLRs, also known as digital single lens reflex cameras, which had a mirror in front of the sensor. The mirror reflected any incoming light up into the viewfinder until you took a photo, at which point the mirror flicked up out the way in order to then let the light get to the sensor to capture a photo. But before you press the shutter button, what you would be seeing through the viewfinder was actually just the light coming straight through the lens itself. It was essentially like looking into the eyepiece of a telescope. There was no sensor involved. Not only that, but preceding DSLRs were film SLRs. And here's a photo someone took of the moon with a film camera. No digital sensor for any AI to mess around with, and yet the shadow side of the moon is clearly still there. And the daft thing is, you don't even need a camera. You can see this with your own eyeballs. The whole thing that Trevor is arguing against here is the idea of Earthshine. But if you catch sight of the moon when it's just at the start or the end of its phase, so only a small part of it is illuminated, it's always near the sun, but you can often see it just before sunrise or just after sunset. It either rises just before the sun or it will trail after sunset. I mean, that in of itself opens a whole can of worms for flat Earth. Why do we never see a full moon near the sun? Or why do we never see a waxing crescent 90 degrees from the sun? There is an intrinsic link between the phases of the moon and its position relative to the sun, which the heliocentric model can easily explain, but what's flat Earth got?
I was curious, what is a full moon and what is a new moon on your model?
I think it's probably like a magnetic cycle, and just like the center of a ferrocell image of a magnet, it's just completely black. It's actually just pure inertia in the center, the ferrocell image of a magnet. I think that's what it is. It just actually goes into its inertial state, then charges back up, and once it becomes like etherically displaced again, you start to see it charge up throughout a cycle.
But I digress. If you can catch sight of the moon around these times, you can actually see the shadow side of the moon with your own eyes. Like, this is a photo I took a few years ago in Morocco just after sunset, and you can see the shadow side of the moon quite easily. Now, sure, Trevor could argue that this was shot with a digital camera, therefore the camera's adding the moon in. But one of the main reasons I took this photo was because I was walking along the beach at sunset, and I could see the full silhouette of the moon with my own eyes. Alternatively, you could just watch a lunar eclipse. You go from seeing a full moon, with its craters, then Earth's shadow starts to cover the moon, and time-lapses show the exposures stepping up as the moon gets darker and darker, and then once the moon's fully in shadow, you can see the surface of it evenly lit, and it's still the same as before, just now it's red. And now, with regards to his other post about the moon's brightness changing between the zoomed out versus the zoomed in, there's two potential explanations for this, or possibly a combination of them. First is that if the camera is set to auto-expose the photo. Cameras have three basic settings that can be changed to control the brightness of a photograph: shutter speed, aperture, and ISO. The shutter speed is how long the camera shutter remains open for to allow light to reach the sensor. The aperture is the iris mechanism inside the lens, which can be opened or closed to control how much light can make it to the shutter in the first place. And ISO, which is sensitivity. In film cameras, this was how sensitive a particular roll of film was to light, with more sensitive films then requiring less light hitting it in order to get a reaction. With modern digital cameras, though, ISO is essentially signal boost. It takes the signal from the sensor and then boosts it, like turning up the volume on a stereo. These three settings together control the exposure in what is known as the exposure triangle. And most cameras will have a fully manual mode where the user can set each of these three settings themselves to whatever they desire. However, most cameras have automatic and semi-automatic modes where you can let the camera control any one, two, or even all three settings for you. The question then is, how does the camera know what a correct exposure is? It doesn't know what you're photographing or what you're trying to achieve with an image. So typically it just aims for a middle-of-the-road exposure where it's not too bright and it's not too dark. And generally it will take the central section of the frame as reference, because that's usually where people will put the subject. But for example, if we look at the zoomed out photo, that's the moon, and there's no shadows from the signposts, so this is clearly taken at night, and there's no clouds in the sky, so that sky should be pretty dark. Yet the whole photo looks way too bright, because the camera is trying to balance a dark sky and road with a bright moon and bright streetlights, and the central region of the photo is mainly dark sky, which the camera is then trying to make more grey, because that's the midway point between black and white. But when you then zoom in and aim at the moon itself, the moon now fills the center of the frame, so the camera is basing the exposure now off a completely different base brightness, and so it will then change the settings accordingly. You can see this for yourself just using your phone, because regular photo mode on most phones actually auto exposes. So if you make your room dark and then switch on the ceiling light, open your phone app up and just look at the room in general. You'll see the phone exposes the room fine, but the light on the ceiling will appear as a bright blob, just like the moon in this image. But if you then hold your phone up and point it straight at the light so that the light is filling the frame, the phone automatically drops the exposure settings to try and make the light more visible, which would be the equivalent of zooming in on photos of the moon in this example. Your phone doesn't replace your ceiling light with a moon. Now, if I set a camera into manual mode so I can control all three exposure settings, I can force the camera to a darker exposure, which will then make it easier to see the details of the moon even when zoomed out. And if I then zoom in whilst keeping the same settings, the moon's brightness doesn't change. This brings us to possibility number 2, which is the aperture. As mentioned already, aperture is the iris mechanism inside the lens, and all cameras display their aperture by an f number. So this lens, for example, is a 12mm f2.8. The f denotes a ratio of focal length to the apparent aperture diameter. So if it was an f1.0, then the focal length would be 12mm and the aperture would appear to be 12mm in diameter. If it's an f4, then that will mean that it's a 1:4 ratio, so the aperture at its maximum would appear 3mm in diameter, meaning the aperture is therefore smaller, so less light can get through. Thus, a higher f number means less light. Now, to clarify, it's not the physical diameter of the iris, it's the apparent size, because as you zoom a lens, you're also magnifying the apparent size of the iris. Hence, if I look through this lens from the front, the iris hole appears much larger than if I view the lens from the back, even though it's obviously not actually changing size. Now, some lenses will keep the same maximum aperture as you zoom in. For example, this is a 70 to 180mm f2.8. So if I have this at 70mm f2.8 and I then zoom in, the aperture remains at f2.8 throughout. So the amount of light getting to the camera does not change as I zoom. However, keeping an aperture constant throughout a zoom range makes a lens more complex to design. So what most cameras have, particularly more budget ones, is a variable aperture. For example, this is a 150 to 500mm f5 to 6.7. So at 150mm, its maximum aperture is f5. As I zoom in, the maximum aperture naturally drops, so that by the time I reach 500mm, it's down to f6.7. If I set it to 6.7 at the start, it will stay as that as I zoom in and out. But if it's ever set to a value that's wider than the maximum physical aperture that's possible at a particular focal length, then it will drop as you zoom. Now, f5 to 6.7 isn't actually that big of a drop. It's less than 1 f-stop. 1 f-stop is half the amount of light. So between the wide view to fully zoomed in with this lens, less than half the amount of light is being lost. If we look at Flat Earthers' favourite, the Nikon P1000, this is an f2.8 to f8. So at the widest view, you get a nice bright f2.8 aperture, but as you zoom in, the maximum aperture drops off to f8, which is 3 full f-stops. So 1 f-stop is half the amount of light, 2 is a quarter, 3 is an eighth. So if the left-hand photo was shot with a P1000 at f2.8 when zoomed out, and they then zoomed in on the moon, they automatically will only be getting 1/8 of the amount of light from the moon hitting the sensor. And just in case Trevor was referring to the change in colour of the moon, since his post includes 2 photos of the moon zoomed in, this is due to another camera setting likely being on automatic, which is white balance. Cameras are detecting light, but the colour of the light often changes. For example, the colour of an object in direct sunlight will look different than when it's overcast. Interior lights can be all different colours. You can get bulbs that are warm, which give off more of a yellow light, right through to cool, which gives more of a bluish white. Now this then impacts the colour that an object will appear. For example, if I set up a photo with this white box and I light it with this light panel, you can vary the temperature of light from this panel between 3200 Kelvin, which is yellow, right through to 5600 Kelvin, which is basically daylight. Well, if the light is at 5600 Kelvin, then the box will appear white to your eye. But if it's at 3200 Kelvin, now the box looks more yellow. Now, we know the box should appear white, but the camera doesn't know what it's dealing with. So the idea of white balance in a camera is it's basically you telling it what color temperature of light you're working with so it can adjust the recorded light accordingly to give you more accurate colors. So with this panel at 3200 Kelvin, the box looks yellow. But if I go in and set the color temperature in the camera to match that 3200 Kelvin, the box now looks white in the camera because the camera knows the light is making everything more yellow than it should appear. But if I then change the light to 5600 Kelvin, but I don't change the white balance setting in the camera's still shifting the colors to try and offset the extra yellow, but the yellow's now gone, so the camera is actually making everything look more blue. Now, cameras give you the ability to dial in specific color temperatures, or they have presets like sunny, cloudy, fluorescent light and such. But most people will probably have the white balance in automatic. But in automatic, the camera can be constantly changing the white balance because, again, it's guessing by looking around the central portion of the frame. So when aiming at the moon, the camera will see different colors if the central part of the frame is over a bright part of the moon or over a darker region. So no, proper cameras don't generate the moon with AI, which we can easily test for with modern cameras, or just use a camera that either predates AI or that isn't digital. And so that's going to be it for this video. As always, feel free to leave your thoughts in the comments down below. If you enjoyed this video and you haven't already done so, then please do consider hitting the like and subscribe buttons, and hopefully we'll see you in the next video.